Forward, go to share screen. Don't worry, you guys will do fine. I have faith in you. All right, so we're gonna go back over this first one. So we'll start from left to right and I'll walk you through how to draw all of these. So when I start, right, I have CH3 and then that's in a parenthesis. So what does CH3 tell me? What does that tell me? Is it in the middle of a line or at the end of a line?
The end.
It's at the end of the line. All right. Yeah, you don't need biochem to take OChem 2. Usually you finish OChem, then you take biochem. Biochem is the third one in the series between that and then inorganic. Okay. So when you have CH3 at the end, when you have parentheses like this, that tells you that it's coming off of this carbon. All right. So it's coming off of this carbon and this carbon. Does that make sense for how we drew those two CH3s off of it? All right. So how many bonds does this carbon have right now? We drew how many carbons coming off that to the left? Just 2, right? So there's a CH3 and a CH3. Does this carbon have any hydrogens as written in the formula? No, there's no hydrogen right after it, right? So how many more bonds does this carbon need to be happy to have a full octet? 2. So that's why this next one has to be a double bond, right? You have to make your full octet. If it's not a full octet, you'll have a charge on that atom, but you don't have one. So does that make sense? So off of this carbon then, you have a hydrogen, but then you have a CH2. So CH2 like that, right? I could have drawn it up, I could have drawn it down, it doesn't matter. If I was to draw it, this is that hydrogen right there, right? But I also have this CH2 coming off of it. Then I go to a carbon and I have an oxygen like that. So is there anything else attached to that oxygen besides that carbon? Nope. And how many things right now are attached to this carbon? Just that carbon, right? So carbons need 4 bonds. So this has to be a double bond O to this CH2 right here. That's the only way I can draw that structure to get all 4 bonds for my carbon. So if I come back to here, this carbon, excuse me, this carbon right here has no hydrogens, but it's attached to an oxygen, it's attached to a CH2, and it's attached to a CH2. CH2, CH2, oxygen. That has to be a double bond to the oxygen. Does that make sense? On the logic behind that. Is there anyone that is just like, I have no idea what you're doing, bro?
Oh, go ahead.
Go ahead.
Are you sure?
Yeah.
So when you're drawing a structure like this, would you recommend just like getting all the carbons in there first and then going back and drawing the double bonds and like seeing like what needs to fulfill the octet?
You can do that if that helps you, just connecting all the carbons first. You just want to make sure. So if it's in a parenthesis, what does that tell me about the location of the carbon?
It's on the end.
It's coming off.
It's coming off of my main chain, or it's either at the end coming off, or it's coming off of the main chain somewhere. So this CH3 is coming off of the main chain, right? So then I have CH2, CH, right? CH2, CH3. So then this has to be this, like that. So you can do what Gwen said and then draw your carbons and come back and add all your atoms and whatnot. Okay? That might help. But how are you guys dealing with this so far? Relatively okay? Does this make a little bit more sense looking at it again?
I think it makes sense, but I think that like in a test setting, this just kind of takes too much time to actually make sure that like, you have all of it. So that's kind of what makes me scared, because like I can work on this, but it's probably gonna take
what's my advice to you when it comes to these problems? Do you remember what I told you last year when you got to a problem like this?
Easiest questions first.
Skip past the hard ones. If you think it's going to take time, skip past it, come back to it, right? Be smart about how you do it. This is why when I'm going to square up with your professors that are being jerks during quarantine, I was going to start with the oldest and weakest first and then work my way down. Bushman was at the end. She seems scrappy and she's tall. She's got reach. Okay, circle and name. Oh, what was that?
I had a whole conversation with someone at Dutch Bros that was working there about Bushman.
Yeah, tell them that you know someone that's willing to square up for you guys.
Yeah.
So what I did for this problem, I counted the carbons that were not in like parentheses, and then I just drew like the main chain,
Mm-hmm.
and then I just went off of that and like went back.
Yep, you can do that too. So you can go 1,
Okay.
2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. Right off of carbon 1, you have methyl. So 1, 2, 3, 4. Off of carbon 4, you have a double bonded O. 5, 6. Off of 5, 6, you have this methyl like that. Is that how you did it?
Yeah.
Okay, and then if you took the time, you would say, oh, there should be a double bond here. And that is the correct drawing too. Does that work better for you, Melissa? I think that's what you were kind of alluding to. So circle and name 2 functional groups of the compound. You do have 2 functional groups in this compound. Functional group A, functional group B. What's this one called? Ketone. This one? Alkene. Double bond alkene, right? And a carbon double bonded to an oxygen. That goes to a carbon, and this goes to a carbon. That's a ketone, right? If I change one of those carbons to a hydrogen, what functional group is this now? Aldehyde. So make sure you pay attention to that. But this ketone and alkene in this one. How are you guys with functional groups? What did I tell you guys to do yesterday? And for those that I've been working with, what have I consistently told you to do with your functional groups?
Flashcards.
Flashcards. This is just memorization. For those of you that are biology majors or are good at biology and are good at memorization, use your skill set, right? Each of you learn in different ways. If you're able to learn things and able to process through memory, like you can memorize stuff, use that skill, right? Use it to the best of your ability. All right. Be smart about how you do things. Okay, consider the compound up, right? Name the indicated 4 functional groups. So go ahead and do this one, fill it in. I'll give you guys a minute or 2, and then we'll come back and do this. Do all 4 parts. I'm going to close my window while you guys are doing that because it's like 40 degrees outside, so it's probably a little cold in here. Whenever you guys are done, the answers are on the board. You guys are slow. Especially you, Bella. Matt, how's it going?
It's going good. I got a couple of them right.
Hey, get your points where you can.
May I ask where the sp2 carbons are?
Yeah, we can do that. We'll wait. We'll give everyone another 30 seconds or so to finish up. Skylar, hanging in there? Excellent. They're delocalized if they're in resonance. And also, if an atom has sp2 or sp hybridization, then it can be delocalized. Typically, you can't be sp3 hybridization. We had lost someone. Someone was here and they left. I don't know who left. Whoever was in the library, I think. That's fine. All right, how are you guys doing on this one? How'd you do? Good, bad, okay. Are you still working on it? Okay, NH2, that's called an amine. All right, if you have a nitrogen and 2 hydrogens, or a nitrogen and 1 hydrogen, that's an amine. Carbon double bonded to oxygen, and if it's a hydrogen here, right, this is an aldehyde. Carbon double bonded to oxygen to OH is a carboxylic acid. So if you see COOH, if you see a carbon with 2 oxygens like this and H, this is a carboxylic acid. And then finally, carbon single bonded to oxygen, single bonded to carbon is an ether. How'd you guys do on the functional groups? Again, flashcards will make your life easier. All right, so I'm going to draw all of the hydrogens in red to make your life easier and so you can see them all. One, two, three, four, five, six, seven, eight, 9. Did you guys get all of those hydrogens? Did you guys miss a hydrogen or did you add a hydrogen?
I
Questions?
got 8.
Which one did you miss?
The OH. I didn't count the H.
Don't, yeah. Watch out for that, right? If you have heteroatoms, make sure to check your heteroatoms. That's an easy place where people miss their hydrogens. Okay, sp2 carbons. What's the easiest thing to give away that something's sp2? If it has a double bond. 1, 2, 3, 4. Are you good there? Guys, see that? If you see a double bond on something, it's most likely sp2. It could be sp if it has 2 double bonds, but if it only has 1, then it's sp2. And finally, pi bonds. Any place you see a double bond, right? So I'm switch to green. 1, 2, 3. That's it. How'd you guys do on that one? How are you guys doing after that one? That one looked like it hit you guys hard.
I think I'm still at like a 7.
That's fine.
Yeah.
You were seeing things. All right, so I'll tell you this. Mag, was that you who said that you missed the hydrogen on the oxygen?
Yeah.
Are you going to make that mistake tomorrow now?
No.
No, you're not, because you made it tonight, right? Make your mistakes tonight. I promise you'll do better tomorrow. Okay. Rank the molecules from lowest to highest boiling point. What is the biggest thing that contributes to boiling point? What's the most important thing?
Large molecules.
Large is important, but there's something. Give me an I. Give me an F. Give me an M. Give me an F. I, M, F. Intermolecular forces, right? All of these have the same number of carbons, so size is not going to tell you anything. Which is the strongest intermolecular force?
Hydrogen bonds.
Yep. So which one can do hydrogen bond? 1, 2, 3, or 4?
1 and 4.
Right? Which one can do more hydrogen bonds?
1.
So I'm gonna give them letters because I think since we have the number, we will call A, B, C, D. Which ones can do hydrogen bonds? And you said A and D, right?
Yes.
Okay. Which one can do multiple hydrogen bonds?
A.
A. So A is going to be 4. Then the one that can only do one hydrogen bond is 3. What's the difference between B and C?
The oxygen molecule?
Oxygen atom, yes.
Atom, yes.
So if you only have carbons and hydrogens, this is something I told you back in 151, you're only capable of what intermolecular force? London dispersion. London dispersion is your smallest. So this will be 1. This is 2. That oxygen makes it polar, so you can have dipole-dipole. Does that make sense for using your IMFs? All right, B, what intermolecular force leads to the lowest boiling point? And I just told you. London dispersion. If you only have carbons and hydrogens, your only intermolecular force is London dispersion. Gwen, if I was to ask you which intermolecular force leads to the highest boiling point, you would tell me?
Hydrogen bond.
Say it with conviction.
Hydrogen bond.
There you go. All right. So also, what's something in this problem that could have helped you with solving part 5 or part A for number 5? In B, it told you intermolecular force. So make sure you read through your entire problem to make sure that you see what it's asking you. Which compound is the most polar?
The one with oxygen.
There's 3 of them with oxygen.
That's true. B.
Nope.
Would it be the one with the highest boiling point?
Boiling point does not play into it here. It's going to be do you guys see why, or are you completely lost on this one?
Lost.
Okay, so every molecule here, right? So this is this here, like this, right? This is 1, 2. Like that. So this is A, this is B, this is C, this is D. Here, your dipole arrows go towards the oxygen like this, right? But they're pointing opposite directions, correct? So what's going to happen to that dipole moment?
Cancel out.
They're going to cancel out because they're pulling in opposite directions. Here, my dipole moment is pulling this way, right, towards my oxygen. But does that have symmetry? Yeah, it's like the same down the middle if I cut in the middle, right? So they cancel out. What about here? Only carbon hydrogen. You don't really have a dipole moment, right? When you have carbon hydrogen, but this one only has unidirectional. Does that make sense? You guys remember when we did vectors way back when in 151 and you're like, this is hard, Dr. V. I don't want to learn this. You're the worst. I've met Hitler and you're worse than him. That's what you guys sounded like. So if you have any of these problems and I ask you about this, find the one with the most electronegative atom. So I think Max said, look for oxygen, right? So I can eliminate C, but then I have A, B, and D. Look for the one then that has the strongest intermolecular force. You can eliminate B, but you can't eliminate A or D. but you can make it D because it's only like one direction, right? I'm not pulling in both directions like A is. So since D's will go in only one direction, does that make sense? Are you guys okay with that train of thought? Okay. Bella, how you doing with that train of thought? Okay, which compound is most soluble in water? A, B, C, or D? What was our rule for solubility? What was the 3-word rule that I gave you for solubility? Or 4-word? Like mixes with like, right? Just like you guys hang out with people that are like you, like mixes with like. So if I think about water, which one of these molecules is closest to water?
B.
Oh, God, no. OH. So water is extremely polar, right? So if it's extremely polar, you want to pick the one that can that can do IMFs with it. So if it can hydrogen bond, right? These can hydrogen bond together because it has that OH, right? So you can form the most hydrogen bonds here. Does that make sense? So if I was to ask you which compound is most soluble with cyclohexane, what would you guys say? A, B, C, or D? C, because these both only have London dispersion, right? So they only have carbons and hydrogen. C should be the one. Does that make sense for solubility? Good luck, Melissa. Send me a message. Let me know how you're doing. Okay. So, are you guys okay with this idea of solubility of like mixing with like, you look at the intermolecular forces. So the molecules that have the most similar intermolecular forces, those are the ones that are going to mix. So since water can hydrogen bond, it's going to mix the best with any other molecule that can do the most hydrogen bonding. Does that make sense? Mag, are you okay with that? You can say no.
I think so. I'm not sure.
Okay, I'll ask you this. Can this molecule do hydrogen bonding with water? Yes, it can.
Okay.
This oxygen can do a hydrogen bond with that hydrogen, right? Remember oxygen to hydrogen like that?
Oxygen. Okay.
But how many times can water, hydrogen, how many places can a hydrogen bond here? In this one up here?
2.
4.
Oh, because there's, okay.
There's 2 OHs, right? So I can
Yeah.
hydrogen bond here. I can hydrogen bond here. I can hydrogen bond here. I can hydrogen bond there, right? So the more places that it can do that hydrogen bonding. Does that make a little more sense?
Yeah, that makes more sense.
It's kind of like if you went on a date with someone, the more things you have in common, the more likely you are to go on another date, right?
I don't go on dates, but
Whatever floats your boat, okay? Whatever frat boy you drag home from the bar at the end of the night, or sorority girl, whatever floats your boat.
oh my God.
Don't let me stop you from living the life you need to live. I don't shame around here. You do you. I had this friend Amy in grad school, and we used to go out, and we would hang out, like not go out, like we didn't date, but we would go out, to the bar. And one time we were at a bar, and she's like, "Boy, that guy's cute." And I said, "I guess." And she's like, "Go get his name." I'm like, "I'm sorry, but we're not in elementary school." She said, "Go get his name." So I went over and I said, "See that girl over there?" I was like, "Yeah." "She wants to take you home." And he's like, "All right." So she went over there and they left. I miss Amy. She's married now. She works in Canada. She was really nice. I miss her. All right. So let's continue on. This question has 3 parts. Suggest the structure for A, C4H80. What was the one thing that you guys should do for this first?
Put a mark at the 3000 line.
You could put a mark at the 3000 line, but there's something even a little bit better for you. Degrees of unsaturation. Always calculate degrees of unsaturation first when they give you a molecular formula. So 2C plus 2 minus H minus X plus nitrogen divided by 2. So that's going to be 2 times 4 is 8 plus 2 minus 8 divided by 2. So you're going to get 2 divided by 2. So that's going to be 1. So what do those degrees of unsaturation tell me? How many double bonds or rings? Pi bonds or rings? So how many pi bonds or rings does this molecule have? One. That's what the degrees of unsaturation tells us. If you do that degrees of unsaturation calculation, has she told you guys this? Right? If you do the degrees of unsaturation, that tells you how many double bonds or rings there are in total. So how many double bonds, I'm asking you guys again, how many rings or double bonds in total do you guys have in this one? 1, right? It's right there in that formula, right? Does that make sense? Mag, do you see that calculation? Do you remember it? Are you okay with it?
So how did you get 2 after the 4? Because I know we have 4 carbons, so then we would multiply 2 times 4.
So that's 8, right?
Yeah.
We add 2, we just add 2.
Oh, okay.
We subtract the number of hydrogens, which is 8, right?
Mm-hmm.
We subtract the number of halogens. We don't have any halogens here, so that's 0. And then we add the number of nitrogens, which is also 0 in this one, all divided by 2. So 8 plus 2 is 10 minus 8 is 2 over 2 equals 1.
Okay.
Does that make sense?
Yeah.
You guys can do this test at home. So what should you have on a piece of paper ready to go?
The formula.
Have the formula ready to go, right? If you are allowed to have your notes, make the most of it, right? Make a very smart. My recommendation to you is that when you guys are allowed to use open notes and stuff like that, have a notebook with pages marked, like have an IR page, have a structure page, have a functional group page. Break everything into how you can like say, know where you're going on your notebooks and say, I have an IR question. Let's go to my IR section of the notes so you have them ready to go. All right. And again, Gwen, or she's busy talking. I'll ask Mag. Mag, what did I say IR is good to? What does IR tell you at the simplest?
I remember this, but it's just not.
Gwen, I know you know this.
Functional groups.
Functional groups. It tells you what functional groups are. Because remember, IR shoots IR light into my sample and it vibrates and does the wiggly stuff. And then it vibrates based on what type of bond it is. So carbon oxygen, carbon double bond oxygen, carbon hydrogen, functional groups, right? So I told you guys 4 things you should keep an eye out for. As I think Gwen just accidentally dropped out. Draw a line at 3000, right? Helps if I turn on my writing tool. So do I have anything to the left of 3000? Nope. So that means that I only have things to the right. What type of bonds are my things to the, if I have less than 3000? sp3 carbon hydrogen. sp3 carbon hydrogen. So I'm going to have carbons attached to hydrogens and they're going to be single bonded. They're just alkanes, right? I don't have any double bonds there. What is the other big functional group that you guys should see right away, right now, that is on this IR spectra?
Isn't that like the aldehyde?
Not an aldehyde. You're correct, but there's a specific term for it. You're too specific. Get a little more general.
Carbonyl.
Carbonyl, exactly right. Carbon double bonded to oxygen. You don't know right now, just looking at that large peak, if it's a aldehyde, if it's a ketone, if it's a carboxylic acid, if it's an ester, if it's an amide, if it's an acyl chloride, if it's an acyl anhydride. You don't know. You just know that you have a carbon double bond to oxygen.
I was talking about the one at the one right next to the sp3, the 2870
That's
one.
that's not an aldehyde.
Okay,
So remember your aldehyde, how many peaks do you need to have there?
2.
At 28 something and 27 something. So we
Okay.
don't have a peak at 27 something. That's your clear indicator. Does that make sense?
Yeah.
Okay. So now that I know that I have that carbonyl, what type of functional group is it most likely going to be if it's not an aldehyde? What's the other one that's like an aldehyde? Ketone. So this would be a reasonable drawing for your thing.
Wait, so where'd you see the ketone again? I'm sorry.
This tells you have a carbonyl peak, right? C double bonded O.
Uh-huh.
If
Oh.
you had a peak at 27 and 2800, like Mag said, right? If you had an IR peak, if you had another peak like this that looked like twins at 28 and 27, that's an aldehyde. If you don't have that, then it's most likely a ketone.
Sweet.
Does that make sense? Gwen, does that make sense?
Yeah, sorry.
No, just making sure. Bella, Matthew, Skylar, Mags, does that make sense? Are you guys okay with this one?
Mostly, yeah.
Okay. Remember, what did I tell you about IR? To treat it as what? Just functional groups. So you should just grab what you know as quickly as possible. Think of it as a puzzle. Don't try to spend too much time on it because you can drive yourself mad. I once made a girl cry during a test because I stared at her while she was taking it. She pissed me off in lab that day. Okay. What's the first thing we should do?
Line.
Not line.
Oh, the formula. The
Formula before you even do the line. The line's a good
Our
thing.
professor,
But-
yeah, our professor was like, line, always line.
Yeah,
No.
so
Okay.
But-
We will say line. I will say line because that's what Dewis is telling us. Draw the line. But now
Yeah,
what's the next thing you should do?
there's an OH.
There's also an OH. Okay, my recommendation to you, right? There is an alcohol. Always do the formula. So 8 plus 2 minus 6. Yeah, so two. So 4/2. So I get 2. Wow, that is, I'm having problems writing. I got 2 for my degrees of unsaturation. So 8 plus 2 minus 6/2 equals 10 minus 6/2 equals 4/2 equals 2. So what does that mean for our problem?
is
We
it
have 2 what?
2 double bonds?
2 double bonds, 2 rings, a ring and a double bond. We just have some combination thereof, right? So like you guys said, the first thing I do is I draw my line. Do I have peaks below 3000? Yes, so I have sp3 carbon hydrogen. Do I have peaks above 3000? Yes, so I have sp2 carbon hydrogen. Do you guys see that? It's hidden, right? It's kind of like tucked away. You can almost miss it. What is the big functional group that is jumping out at you?
An alcohol.
It's an alcohol, right? This is as clear a sign as you can get that that is an alcohol.